Okay, so magnets, question 5, part B. The student increased the current in the wire. Sketch a graph on figure 2 to show the relationship between the current and the magnetic force on the wire. Label the axes with the independent variable on the x-axis, okay? It's worth 2 marks. So the first thing I'm going to do is on an x-axis there. What are we going to do? So increase the current on the wire. So the current is going to be the thing that that we change here. So current is going here. Current and magnetic force. So we're going to have magnetic force will be the other value. Now, what I might do here is I might think, right, is there an equation I know that links magnetic force and current on this wire? And there is. And that equation is F is equal to B, I, and L. Okay, and what I've got here, this is the B from the permanent magnet. Field strength, and this is the length of the wire. Well, I know that they're both constant, so they don't change at all. So what I've got there is I've got force is therefore proportional to I. And the gradient of that line would be B times L. So because they're proportional, BL is going to be constant. This is the moment where I was about to be lazy and not use a ruler, but let me just, I've got a pencil here I can use as a line, so it will be a straight line going through the origin like that. Okay? And because I know here, I know the force, this is F, I know that's I know that gradient, I'm going to write this in because I think about the gradient, which is equal to, so this is of the form y equals mx plus c. Well, I know c is 0, c equals 0 because there is no c here, but I know the m, the gradient is b times l. Gradient equals b times L. I'm showing off a bit there, but if I know it, I'm going to put it in to show that I absolutely know it. Be careful. Yeah, careful you don't want to get it wrong, I guess. C. The length of the wire in the magnetic field is that. The current in the wire is that. The reading on balance is that. Gravitational field strength is this. Calculate the magnetic flux density of the permanent magnet. Okay, of the permanent magnet. It's worth 5 marks. Okay, so we're going to go back to, we've got lots of, so current is that, we've got reading on the balance is that equals M. So it's a mass, be careful there, so we need to convert that into newtons. Length of the wire is that. We know we're going to need for this, we've got our wire there, our wire has been pushed up by F equals BIL, okay, and it's pushing everything else down with W equals mg. It's not accelerating, it's staying where it is, which means we know that F is equal to W again for this. Okay, so this is a very similar question, I guess, to the one before. A lot more space though in this one, which is useful. So let's just separate the answer space up. I'm going to make this one a little bit, middle one a bit bigger this time to help myself out. I ran out of space when I did this last question. So first thing is I'm going to have to work out. So I want to find out what B is. So I'm going to find out. I'm going to convert that. I'm going to convert that reading on balance into weight, and F is equal to B I L. Okay, there are 2 equations. I'm going back then to write down my values and convert if I need to. So I've got length of wire L is equal to 4.8 times 10 to the minus 2 meters. Okay, that's fine, it's in meters. I've got I is equal to 0.80 amps. Okay, I'm happy with that as well. And I've got, I'm going to leave those for a minute. I'm going to put little gap here because I'm now looking at the mass and the gravity. So I've got m is equal to 1.2 times 10 to the minus 3 kilograms, and I've got g is equal to 9.8 newtons per kilogram. So no conversions at all in this one. Okay, so I'm interested why. Well, I can see, hopefully, I can see why it's worth 5 marks, why it's worth a bit more. And that's because I've got to find the weight again over here. So I'm then going to enter the values into here. So I've got 1.2 times 10 to minus 3 times 9.8 gives me a total weight of 0.01176 newtons. Okay, so I get that. I'm then going to substitute my values into here that I know. So I know that W equals F. I'm just going to restate that. So F is going to be over here. It's going to be 0.01176 is equal to B times the current, which is 0.8 times by the length, which is 4.8 times 10 to the minus 2. Trying to simplify that a little bit, so 0.8. Oops, so my calculator's not playing at all. What's going on here? There's my calculator, there we go. So 0.8 times 0.8 is equal to, so it's 0.01176 is equal to B times 0.0384. To rearrange that. So I've done my substitutions. I'm now going to rearrange and solve. So I want to rearrange to get B. So I'm going to divide both sides by this. So B is equal to 0.01176 all over 0.0384 gives me a total value of 0.31 Tesla. Okay. So that's it. So in terms of the marks, I would get, let's see, what would I get the marks for? I'd get 1 mark for identifying that the weight is equal to that. I'd get 1 mark for quite possibly the substitution there. I'd get 1 mark certainly for the substitution there, 1 mark for converting there, and 1 mark for the answer. Okay, hope that's useful. Take care.